Welcome, guys. I'm about to introduce my first video. This video is on the mathematics series. Is the one I want to introduce now. So the video is on the mathematics series. So in these videos, guys, what I will be doing is I will be alternating a slide and then explanation. So the explanations are self-explanatory, so you don't need to worry about it. So guys, welcome to my mathematics series videos. The first video on these mathematical videos is explaining the rationale behind these videos. And so every video, and in particular like now I have this one here, is intended for students who have mathematics as a compulsory subject or who have done it before but so long ago that they feel they have forgotten it all. Then a subsection, how to use this video. You not gain much by just watching this video. Have a pencil and a paper ready to work through the questions before reading their solutions. Remember, I've also given questions and their solutions. So don't look at the solutions and do the question. Do the question, and maybe if necessary, you look at the solutions. So you are supposed to read each question carefully before attempting it. It is important that you try hard to complete the questions on your own rather than refer to the solutions as you are stuck. If you have any difficulties with the questions, go back and study the textbooks in more details. So don't just look at a question you are stuck and then you look at the answer and then you pretend that you have understood. You have to go back and read the textbooks. There will be a video on the reference books later. Okay. So next we look at what this video is all about. And so welcome. So this video is designed to prepare students adequately for any mathematics examinations for all levels of education, from Form 1 to the university level. And the outstanding features include systematic organization of the steps that make the video relevant to the students with a mathematics background to use it conveniently. The video is ideal for students in lower and upper classes. It is also an appropriate reference video for teachers and university students. The video draws extensively from the author's experience as a mathematician, a mathematics teacher, and a senior examiner with the Kenya National Examination Council in Kenya. Africa. So here I'm just trying to tell people that I'm a graduate of the Kenya Science Teachers College and the University of Nairobi. I was a senior head of department and have a wide experience of teaching mathematics in secondary schools. The next video, not a video, sorry. The next slide, I'm talking of video. The next slide, remember I'm using PowerPoint. So the next slide is giving you some advice. Welcome. So, my fellow viewers, the time has come. The future is here and it is called Mathematics Made Easy. This revolutionary video is here to change the world, and we must embrace it with all our strength and determination. I know that many of you are eager to try watching for yourselves the videos for the first time. And I assure you, we are doing everything in our power to make that happen. I'm working tirelessly to accommodate the incredible demand for videos of this type. But I want to remind you that being good in mathematics is never achieved without sacrifice. And the road to the future of great mathematicians will not be without its challenges. So please be patient, watch the video to the end, give it a like and comment to help improve the content, and don't forget to subscribe to this YouTube channel. The next slide is introducing my videos in mathematics. I want to introduce them. Welcome, guys. So, mathematics as a subject helps people apply ordered, sequenced, and logical approach in dealing with life's problems. This video is so arranged that the subject matter is presented one step at a time and is teacher-friendly. The questions are examination-oriented and provides numerous exercises for practice. So I've given some quotes here. Were there times you believed everything was lost? It was simply the beginning of your improvement. It's not important the time of life when you're tired. Important is it is always possible and necessary to restart. Rebirthing is a new opportunity. It is renewing the hopes in life, and more importantly, it is believing in oneself. If we think small, the small will come. If we think firmly on the best, on the positive, and we strive for it, the best will come in our lives. And this one is a quote by Anonymous. Most students enjoy a subject if they are able to achieve some measure of success in that subject. It is my sincere hope that the students and teachers who watch this video will find it interesting. So, the next is, I now want to start the video in detail, guys. So, Welcome, welcome, guys, to mathematics. Mathematics is very enjoyable. Okay, if you like mathematics, it likes you. If you hate mathematics, you are not friends. Just have that love for the subject, and everything flows internally, and you achieve very good results. So, what I will do is I'll first of all go through the lesson plan very fast. Before now, I come to the details of indices, because this past series of the videos is on indices and logarithms. So before I come to details, I'll just give you a lesson plan of today's lesson. Welcome, guys. So if you are a teacher, the lesson plan is titled is Indices in Mathematics. It is grade level 9 to 12, that is high school. And the subject is mathematics. Duration, if you want to achieve good results as a teacher, should be 60 minutes. That is actually a double lesson. And the lesson objectives are as follows. The learners should understand the concept of indices. The other name of indices is exponents and their notation. Second objective is that the learner or the learners must learn the rules of indices and how to apply them And finally, the learners should be able to solve problems involving indices. So, we have materials which you require, and you require a whiteboard and markers, a projector, and a computer for presentation, handouts with practice problems, graph paper and calculators, index cards with definitions and examples, worksheets for class activity. But if you don't have a projector or computer, it's not an excuse not to teach this lesson. You can omit the materials which you cannot afford. The outline of the lesson will take about 10 minutes. And the first thing you do as a teacher is you have a warm-up activity where you begin with a brief review of multiplication and division as they relate to indices. Ask students to write down what they know about exponents or indices and share with the class. Number 2 is the objective overview, where you introduce the topic by explaining that indices are a way of expressing repeated multiplication. The next step in your lesson plan should be direct instruction, which takes about 20 minutes. Here, you are going to give the definition and you show them the basic notation, where you explain what an index or exponent is. And here you can tell them it is a number that it tells how many times to multiply the base by itself. And you give an example there, like 2 cubed is equal to 2 times 2 times 2 times 2, which results in 8. Number 2 is you go to the rows of indices. So you name them, and then you give an example. For definition and basic notation, that example I've given is not exhaustive. You can give more examples. So in the laws of indices, we start with the product, the law known as product of powers, and it is a raised to m times a raised to n equals a raised to m plus n. And we give an example there where we have 2 cubed times 2 raised to 4 is equal to 2 raised to 3 plus 4, which is equal to 2 raised to 7. So you can see now 3 and 4 represents the m and the n, and a represents the base. Okay. The next row is quotient of powers, which is a raised to m over a raised to n is equal to a raised to m minus n. And we give an example there of 2 raised to 5 divided by 2 raised to 2, which gives you, using now the formula there, because m is 5 and n is 2, you have 2 raised to 5 minus 2, which is 2 cubed. The next one is power over power, where you have a raised to m, so that power is raised to n, which is equal to, like you have a, then you remove the brackets, you multiply m times n. And the example there is 2 cubed raised to 2, which is equal to 2, 3 times 2, which is equal to 6. Remember, guys, I will come to the proof of these laws in details, and in this topic, we will be repeating some of the things so that by the end of the videos, nobody can complain that you don't understand indices. The next law is power over product, where you have now like AB is a product which is raised to m equals a raised to m times a raised to m. So you distribute the m to each of the values of the product. And so therefore we have something like 2 times 3 bracket squared is equal to 2 squared times 3 squared, which is the same as 4. 2 squared is 4, and 3 squared is 9. When you multiply them, you get that 6. Power over quotient. You have a over b. A divided by b is a quotient. You raise it to m, and this will give you now each of the parts of the quotient, that is the numerator, and the denominator gets the index, so that you have a raised to m over a raised to b raised to m. And the example there, you have 2 over 3, which is squared. The numerator 2 gets the 2, and the denominator 3 gets the 2, so that you have 2 squared over 3 squared, which gives you 4 over 9. Number 3 is the negative indices. So we are through with the rows, but there are there's another area of indices where students have problems, and this is in negative indices. So if you have an index like a raised to negative n, remember a is a general base. A can be any number from 1 all the way, as long as it is not negative. So a raised to negative n is equal to 1 over a raised to n. Guys, these laws, we are going to prove them. So you don't need to be scared. You just need to search for that video which is showing you the proof of the laws of indices. So the negative index now, we have the example which is 2 raised to negative 3, which equals to 1 over 2 cubed. Remember, our a is 2 and our n is 3, and therefore it is 1 over 2 cubed, which is 1 over 8. And finally, we should never forget the zero index. Guys, sorry for that interruption, but we have just cleared the negative indices. So let me come to the zero index. We will explain later with the videos why a raised to 0 is equal to 1. So if you raise any number to 0, the value is always 1. So a raised to 0 equals 1 for any non-zero number a. So as long as a is not equal to 0, so you cannot have a raised to 0 raised to 0, because 0 raised to 0 in mathematics we say is undefined. Is something you cannot do. And so we give an example there, like 5 raised to 0 is equal to 1. And any other number, apart from a negative number, if you raise it to 0, the value is always 1. And this one will be proved. So after you highlight that, you go to the guided practice, where you have group activity. In the group activity, you divide the students into small groups and provide index cards with different problems involving indices. Index cards are cards or manila papers where you have written the problems of indices, and then the students are given to solve. So each group will solve the problems and explain their solutions to the class. So if you, for example, you have 30 students, which is normally the maximum, you can divide them in groups of 5, and you have 6 groups, all right? So each group will choose somebody who will present their results. After the group activity, let them do class discussion. In the class discussion, discuss the answers as a class, ensuring understanding of each law and application. Next, after that part of the lesson plan, you go to the independent practice, which will take about 10 minutes. The first part, you can have worksheets. You distribute worksheets with the problems involving various laws of indices. And then the problems there in the worksheet should increase in difficulty, including basic calculations and more complex expressions. We will be seeing some of these issues in the other videos. And the second part, although it is written number 1 here, this should be number 2, is individual work, where you allow students to work on. So you allow students to work on the worksheet individually, providing assistance as needed. Conclusion is our last part of the lesson plan, which will take about 5 minutes. You review, summarize the key points of the lesson, reiterate the laws of indices and their applications, and then exit ticket, ask students to write down one thing they learned about indices and one question they still have. After the lesson, you know that we have 2 types of assessments. We have formative assessment, all right? The assessment you give after the lesson, and then you have the summative assessment, maybe at the end of the term, and so on. So observe student participation during group activities and class discussions. Check for understanding through the worksheet and exit ticket. Then in summary, you are going to give a quiz at the end of the week covering the roles of indices and related problems. So, extensions and differentiation for advanced students, that is those who are in the university or higher classes, like if you are in GCSE, where you have Form 5 and 6. Advanced students provide more complex problems involving indices, such as solving equations with indices and fractional exponents. Encourage exploration of exponential growth and decay in real-world context. Number 2, for the struggling students, offer additional support through one-on-one or small group tutoring. Provide simpler examples and step-by-step guidance on applying the laws of indices. And number 3 is integration with the technology, where you use online tools and apps for interactive practice with indices. Show videos that explain the concept of indices and their applications in different contexts. By following this lesson plan, students should gain a clear understanding of indices, their properties, and how to apply this knowledge to solve mathematical problems. So, there is acknowledgement there. That is, this work is a team effort. There are too many people who inspired me to come up with the production of this video, and I thank them with all my heart. I would also thank my family members for their support, encouragement, patience, and tolerance during my long hours of typing the content of this video in Microsoft PowerPoint 2010. I'm grateful to ChatGPT for assisting me to polish my video. Every effort has been made to contact all the copyright holders, but if any have been inadvertently overlooked, I will be pleased to make the necessary arrangements at the earliest opportunity. I tried as much as possible to get permission to reproduce the items where third-party owned material is protected by copyright holders, but if any items requiring clearance have unwittingly been included, the publisher will make amends at the earliest possible opportunity. Finally, guys, this video may not be reproduced in any form whatsoever, in part or in whole, without the express permission of the creator and designer, except when the video is being used for educational purposes only. And there you have copyright, Medamo TK, who is me.